This podcast is brought to you by the School of Advanced Study, University of London.
Well, I'm really excited to be here today talking about olfaction. It's a privilege talking about olfaction all day with different perspectives, and it's just fantastic. So I will start from our general knowledge about, we were all told that most of what we call taste or tasting is essentially, when we eat, is essentially smell or smelling. But nevertheless, we go on and talking about tasting. We talk about tasting cup and wine tasting and beer tasting, tea tasting, all sorts of tasting, right? Why is that? Probably it's worthwhile thinking about why we do that. So probably the reason people think about taste and smell so separately is because a lot of all this field is developed in the view of anatomy and physiology. So for that matter, taste is basically where taste receptors are all in the mouth, essentially. And then very much separated from olfactory receptors, which is in the nose. And then the way taste chemicals are perceived is through diffusion in the saliva, and it's always perceived in the mouth. For the olfaction, it's always through current of air. By these definitions, it's interesting to think about how olfaction is very unique. When we think about olfaction, we always think about orthonasal olfaction, which is the air is going through the air while we inhale the air. But what we don't really think about is that when we exhale the air, there's another way we can smell our object in the mouth, essentially. So just like Jay was talking about, olfaction is distance sense, and then that's how we perceive external environment, and the way we communicate with what is outside in the environment. Versus what we don't think about is that olfaction also play a role to communicate and to figure out what is in the mouth. And then my talk is essentially, we'll talk about object in the mouth, communication with object in the mouth. So for that matter, while we talk about taste and smell so distinctively, probably taste and smell play a very close interaction. Back in 1966, J.J. Gibson was talking about, well, maybe taste and smell are not that distinctive senses, but probably part of the chemosensory perceptual system for perceiving food in the mouth. So essentially, it's multisensory flavor system we're talking about, instead of talking about taste versus smell. It's like what Jay was talking about. It's like function follow the system. It's potentially we have a function of perceiving food in the mouth, so then we have system, or we have system to achieve the goal. So in the past couple of years, one of my research area has been how taste and odor interact. And we were interested in sensory phenomena with taste interactions, as well as sensory and cognitive factors underlying them. The two phenomena we have been focusing on are return to odor referred to the mouth, and also odor enhancement by taste. And then how does it work, in what condition it works, and what are the potential implications. So one of the most common phenomena we talk about is confusion between taste and retronasal odor. And it's always resolved as a taste. People get confused and people think about it is a taste. And why is that really? For a very long time, people believed, since back to 1917, that's how far I found the evidence. And back then, people thought about, well, because it's a tactile sensation, it's happening in the mouth. So the hypothesis has been due to the customary presence of sensations of pressure, temperature, movement, and resistance, which are localized in the mouth and in the organ of taste, so that odor referral is happening. So we wanted to, this hypothesis has been there for almost 100 years, and then no one tested that. So we wanted to see whether that's really true or not. So we created this odor delivery device, we called it, and we basically, a simple jar, has odorant at the bottom and have a big head space. And this device was allowed us to present odorant in the presence and absence of gustatory and or tactile stimulation. So essentially what we did was that we asked the subject to inhale the odorant in the jar, which was either vanilla or soy sauce in original study. So while the subject is inhaling the airspace of the odor, experiment at the same time presented either air, water, and taste in the mouth, essentially. Then the test was pretty straightforward. Subject was asked, well, tell us where you get either vanilla or soy sauce odor. And then after consulting this oral cavity lab. So as you can see, when air was essentially pumped, so essentially nothing, but they are just smelling retronasal odor, people, about 40 to 45% of people reported that either vanilla or soy sauce was coming as if from in the mouth. So that was kind of interesting because odor referral seems to happen even if there is nothing in the mouth. So there was similar data by Dana Small, and her data suggested that, well, when there were food-related odorants perceived retronasally compared to orthonasal way, there is activation in central sulcus area where oral cavity somatosensory stimulation is happening all the time. So it seems like odor referral can happen in the absence of taste or tactile sensation in the mouth. So at the moment, we really don't know why that is happening. But one possible explanation is that depending on airflow, what direction the air is coming from, the absorption of odors to the olfactory epithelium can change the pattern of activation. So then we perceive differences between orthonasal and retronasal odors. What was interesting for us was that our original hypothesis about tactile sensation. So when we compare the presence of air versus water, the frequency count for nose, oral cavity, and tongue were essentially about the same. There was, in a way, like, oh, shocking. Why is that happening? Like all these hundreds of years of hypothesis, this seems like that's not it happening. When we looked at different odorants, the same thing happened. Tactile sensation didn't do anything. So that gave us the idea that, well, somatosensory stimulation, like what we thought, didn't do much. It's not mediated through somatosensory stimulation. What was interesting instead was when other certain tastants presented in the mouth, odor referral happened dramatically. So for example, for vanilla odor, it was sucrose causing so much odor referral. For soy sauce, it was NaCl, sodium chloride. They causing so much odor referral. So that gave us the idea that, well, probably the presence of a congruent taste significantly increase odor referral to the mouth, especially to the tongue. So once there is congruent tastant existing, people perceive odor as if it's coming from mouth dramatically. And until you experience it, it's just like, it's hard to imagine, but that's how, it's happening. So we had this idea about like, well, that's exciting. But then the way we did the experiment was very unnatural. Who perceived odorant to separate from the air, although it was retronasally? And then there is a taste going on, there is air going on. I mean, it's very unnatural. So we did a very similar experiment using gelatin disc. Very simple study. We made a gelatin with and without tasted. And then also gelatin disc provided such a, a very common food tactile sensation. So unlike, air versus water, now there is a gelatin appropriate texture going on. So we did another experiment. What happened was that when odor was alone with appropriate tactile sensation, the proportion was about the same. So it didn't increase any odor referral, the degree of odor referral. So it seems like tactile sensation was really not causing any differences. But interestingly, as you can see, when there are different kind of tastes in the gelatin disc, the degree of odor referral was very different. And it seems like when it gets more and more complex and closer to food-like, the referral went up. Like degree of referral occurred more dramatically. So it seems like the presence of congruent taste or taste, like mixture of taste, significantly increased odor referral to the mouth. So that caused us thinking that, well, how do we measure congruent? And what are the congruency? And what are the roles of a congruency? So we did another experiment modulating the degree of congruency. So next experiment, we gave citral with sucrose and citric acid and combination of sucrose and citric acid. And as you can see, by adding sucrose and citric acid together, odor referral seems to happen a lot stronger degree. And we also measure the degree of congruency directly between tastant and odorant. And of course, the sucrose and citric acid mixture was perceived to be a lot more congruent with citral. It's like lemonade. Instead of lemon or lemon and sugar, now it's like real lemonade. Similar things happen with coffee. We got this quote-unquote sweet coffee. And we asked subjects to rate congruency as well, degree of congruency as well. And as you can see, sucrose and caffeine combination was perceived to be most congruent. Next was sucrose. And caffeine itself was not quite congruent. And so that didn't cause odor referral too much. So it seems that the degree of taste odor congruence also modulates the degree of odor referral. That was the conclusion we got. So out of this, what we was thinking is that, well, when taste and odorant are perceived as congruent, they essentially causing the flavor component to merge together and integrate together. And instead of getting two different information from two different senses, it's essentially perceived as unified percept. It's one object idea. It's a flavor object. Instead of two separate, three separate information, we have to process it separately. It's one idea. And then it is referred to the mouth. Potentially because airflow, the direction of airflow. So how does that work really? I mean, it is unclear, but then I think what is happening is that just like what we're talking about component of, different order categories or attributes, Now it's different senses in a way, but then it's in the same system. We're talking about taste and odor are also different kind of information. When the patterns are matching with what we know as known flavor object, now is automatically perceived as flavor object. It's a kind of pattern matching idea. Instead of getting, well, there's one going on, there's another going on. But pattern is showing that it is like a banana. It is like coffee or sweet coffee. So when things are matching, integration occurs automatically, potentially. And a supporting idea has been that neuroactivation for congruent taste and odor pairs are much, much greater than the sum of activation by the component presented separately. And then those are happening in insular area. So second kind of interaction we have been studying is that how taste and odor interact in terms of intensity. For a while, people believed that taste is enhanced by odor. And that was back to 1988 when Frank and Byram started thinking about those. And then later on, Frank himself published out, well, okay, this phenomenon occurs only when the rating test lacks a suitable response category. So it turns out to be response bias, simple response bias. So this whole line of study kind of went down. And it was called the dumping effect. So while we were looking at it, like when we were working in the lab, we had a couple of moments that like, you know what, actually that is not really the case. There is something unique things going on in terms of intensity. So we did some experiment by creating the situation that avoided dumping. So we provided all possible categories to rate. So not only rating sweetness only, now we ask subjects to rate sweetness and sourness and saltiness, all possible category, as well as we called, in the first experiment, we called it as other for odorants, essentially. And what we saw was that there was not much enhancement in terms of sweetness or sourness or saltiness. But what we saw was that dramatic enhancement in terms of smell. So for citral, when citral was presented alone versus citral and sucrose, or citral and sucrose and citric acid together, citral was perceived a lot stronger, but not with NaCl nor citric acid itself. So that was interesting. So, okay, seems like instead of taste is enhanced, odor seems to be enhanced. Why is the case? What are the conditions? And then this was one of the most interesting moments that my undergrad student was working. He was a very smart undergrad honors college student. We were talking about things and then like, wow, you know, odor enhancement, we all know the odor enhancement happens. Well, what are you talking about? No one thinks that odor is enhanced. Instead, people think that taste enhanced. Like, oh no, that's not true. We all figured that out, that is true. It's like, how? And so, well, there is this product, I will bring it tomorrow. So he goes off and bringing this box of vanilla custard. It's ready to go vanilla custard. So I looked at ingredient. It says all this like maltodextrin, all sorts of other stuff with the vanillin in it. There is no sugar. So direction says you add sugar, it will be vanilla custard. So that's the data essentially what it is. So in the very left, it says none. There's no sucrose. It comes with vanillin. So when we ask the subject to rate sweetness and vanilla flavor, it's below barely detectable level. It's essentially nothing. It's like a maltodextrin with custard texture in it. So we added 0.2% of vanillin. Of course, vanilla flavor goes up. Nothing surprising. What was most striking was that when we added sucrose to that custard formula, vanilla flavor goes up dramatically. It's the same, exactly same product. Without sugar, it is not noticeable. It's not at all vanilla custard. It is just like plain and nothing but plain custard. But all of a sudden, by adding sugar, it's dramatically, distinctively vanilla custard. So that's the moment like, wow, actually, odor is being enhanced. How does it work? Why that work, right? So we were searching for conditions. So we tested, well, let's check on roles of intensity and stimulus quality. So we're checking on intensity. So at left side, so you can see when citrus was present alone, that's blank. And we had different kind of stress concentration. So as you can see, by adding sugar, odor citrus flavor is being enhanced from A to B. And then this effect is a lot more dramatic when citrus is perceived to be weak, very weak, or sometimes even barely detectable. When it's barely detectable by adding sugar, all of a sudden people start recognizing, oh, there is a citral. And by adding more and more sugar, it doesn't increase any further, causing any further enhancement. But by adding certain amount of sugar, enhancement just happens. So it's potentially trying to boost the signal by adding congruent taste. That's what we thought. In terms of sweetness, by adding more citral, sweetness doesn't do anything. No more enhancement occurred. What about quality? So what kind of quality is causing enhancement? So in the first experiment, we had citral and sucrose, citric acid, and caffeine. Only one caused enhancement was sucrose, not even citric acid. So when we looked at congruency, sucrose was perceived as most congruent. Citric acid was fairly congruent, not as much, but it was pretty congruent. But they didn't do the job. Caffeine was not at all congruent, and it didn't do anything, of course. So it was kind of puzzled why that is happening. So we did another study using different odorant. This time we had coffee flavor, and we were looking for specifically dark black coffee-like odorant, and we got that. So again, sucrose causes odor enhancement. Once you add sugar, coffee flavor seems to be much stronger. Interestingly, caffeine itself was very, very congruent with coffee odor, but it didn't do the job either. It didn't enhance. So what's going on, right? So it seems like unlike odor referral phenomenon, case of congruence is necessary condition but not sufficient condition for odor enhancement to occur. So what are the other conditions then? So we tested, well, let's work on different odorant. So we looked at tomato and chicken. So as you can see, in both cases, NaCl, MSG, MPG enhanced both odorant, but none of the others have done it. Didn't enhance the odorant. So at this point, what we are thinking is the presence of nutritive taste also required for odor enhancement to occur. So what do I mean by nutritive taste? A lot of times when I talk with nutritionists, well, sodium is not nutritive taste. Yeah, I agree. But what I meant by nutritive taste is taste that signals the presence of a macronutrient that we need to survive. We do need carbohydrate, we do need protein, we do need sodium salt. So it seems like when those three components, three categories of taste present with congruent odor, odor enhancement seems to happen. It's not completed study yet, but I think that is most possible hypothesis. So it seems that nutritive taste enhance congruent odor intensity. By doing so, probably what is happening is increasing salience of a flavor. So then it helps us to recognize the potential source of a nutrient and their metabolic consequences. So in the end, taste and olfaction plays a totally different role. Taste is more of carries information about what is in it, how important us in terms of nutrients for us. Versus olfaction is more of an identity. Other than that, in food system, olfaction, what is a really function of olfaction? It's more of, well, okay, that is strawberry, that is raspberry. So what are the differences between two? Well, in terms of a taste components, about the same. It's got sugar, it's got sourness. But other than that, how do we separate them? Based on olfaction. It's identity provider, basically. So it's most efficient to enhance the identity so that we can identify the object better. And this idea of, well, nutritive taste can enhance olfaction have been supported by, again, Dana Small's group, that the anterior ventral insula preferentially communicate with the feeding network in the presence of nutritive taste in the mouth. When there is nutritive taste going on in the mouth, then there is a feeding network is communicating a lot more. So retronasal odor referral is essentially manifestation of convergence in the flavor network, how taste and odor are combined and creating flavor object. Versus retronasal odor enhancement by taste, not the other way, is not only convergence between taste and odor in the flavor network, but also communication between flavor and feeding network to highlight the physiological significance of the stimuli. So just like I was talking about, confusion between taste and retronasal odors are resolved in taste, and then it is happening in the mouth. And then there's just symbolic things that, well, we recognize flavor and convergence happened. And in terms of odor enhancement, is to boost up the identity of known safe food, and it is critical part of flavor perception. So I think that's a big role of retronasal olfaction in food recognition. Yeah. So thank you for inviting the workshop and all my collaborators and my students who worked in this project.
Thank you very much. That's excellent. Thank you very much. Barry's going to give us a commentary.
So thank you very much, Juyun, for the talk, and also for the work of yours that I know rather well. I'm great fan and admirer of your work because I think it supports something that I'm committed to, not just in beliefs but also in print, and that is the idea that flavors are really objective and out there and not just created by us. So, familiar enough thought, I hope, to everyone that despite the fact that people think that what they're tasting is just with the tongue and everything's happening in the mouth, we know that the experience of tasting is based on this huge multimodal combining of information from touch, taste, and smell. And this results in this single, rather unified flavor experience, a kind of percept of the flavor, or as people say, the taste of things. But when you know that flavors are actually, or flavor experiences are actually created by this multimodal input, and it leaves you to ask this question: are flavors, what are flavors? Are they just constructs of brains? You might think that there aren't flavors until creatures with brains like ours put together information about touch, information about retronasal olfaction, information about gustatory taste, and so on, and that's when flavors actually appear in the world. That's certainly the view that John Prescott has, and it's now I think the predominant view in neuroscience. So is flavor a construct of the brain? Neuroscientific community typically say yes. Here's Dana Small saying it writ large. Flavor is in the brain, not the food. It's the brain that integrates the discrete sensory inputs from the food and drink we ingest to create flavor perceptions. No, no, no. She just conflates things beautifully in that very quote. Distinguish between flavor and flavor perception, sound and sound perception, color and color perception. So she's right, look at the second sentence. It is the brain that integrates discrete sensory inputs from food and drink we ingest to create flavor perceptions. But the question is, what are they perceptions of? And if they're perceptions of such things as flavors, it doesn't follow that flavor is in the brain. It might, for instance, follow that flavor is a configuration of sapid, odorous and tactile qualities that have configurations in some aspects of nature, and it's the job of our flavor perception to track them and to guide and select food choice, make successful food choice. Now the problem as I see it for the flavors a construct of the brain brigade is that they have to tell us what are the components of flavors. Flavor experience is all the same. What are the components? And here you have many definitions. I mean, I could have found you more, but here's the one I like in particular is AHRC. This is what used to be the International Standards Organization. It's international because the French created it. That's why it's language of God. So they say flavors are a complex combination of the olfactory, gustatory, and trigeminal sensations perceived during tasting. The flavor may be influenced by tactile, thermal, painful, and/or kinesthetic effects, covering the bases, right? Then we have Charles Spence putting in all of that, but saying touch and so on. And then we have a contrast with Bartoshuk and colleagues. Because if you look at what they include different things. So Spence and colleagues, Aubrey and Spence, have everything that went into the first part of the AHRC and so on, and we'll see that they want a lot more. Whereas Bartoshuk says it's only taste and retronasal smell. Touch isn't in there. Touch is what she thought joined them, but it's not in there. So now you have conventions of taste and smell conferences where people get together and they all know what the science is. They know what's actually, a lot about what's actually going on. Not all, but a lot. And they agree about what's going on, but they don't agree in how to classify or combine these elements and to say where does flavor begin and end. So how do we do that? Well, psychologists tend to be maximalists. Here's a nice quote from Martin Yeomans. Arguably, multisensory integration may be at its most extreme in the case of flavor perception. Few other experiences offer the opportunity for concomitant stimulation of all the major senses. Gustation through the 5 primary tastes, maybe 6. Olfaction through both orthonasal and retronasal stimulation of olfactory receptors by volatile compounds released from food. Mechanoreception, chewing contributing to our perception of texture, providing information on temperature, pain arising from oral irritants, hearing that results from sounds and vibrations. Vibration is part of it too. If I had got a little sample for you, if you give people Szechuan pepper or a solution of Szechuan pepper, and you dip cotton bud in and rub it on the lip, people say, oh, it's burning, but of course it's not a burn at all. It's a bit like an electrical sensation. It's actually the lips resonating at 50 hertz, and you can stop it by just touching the lip, because it's resonation, that's all it is. So there are many, many different things go in there. What do we want? And once you've decided what the components are, you'd have to decide how they get integrated, which was Juyun's question. So is it just a combination? Is it a blend? Is it an interaction? And really the question is, where does the unity come from? Well, a big clue is that multisensory integration tends to take place when you're getting a simultaneous lock on something that's environmentally quite complex. So if you're using sound and vision, or you're using haptics and vision to try to get a hold of something, maybe you have redundant information, but often you'll get information from many sensory channels locking you onto a single unified object. Now, if that's largely true for a number of different cases with the other senses, why would the flavor system be different? Why would it be that the brain does a lot of multisensory combining to try to keep track of objects or events out there that it needs to be aware of, but when it came to flavor, it's just construct something in your head. Just give yourself a nice big melange of information, but don't worry too much about what's going on out there. You're very odd. So if we're going to see continuity with the other senses, we really should see that it's not like that. So I think the unity assumption has something going for it. But now we ask, back to our problem for the construct of the brain people, what goes into flavor? Is color part of flavor? Well, we certainly get information about what foods should taste like, and it's very much influenced by what color they are. Would you eat that strawberry? Probably not. If it's red, it's fine. If you're having a lemon, it should be yellow. If it was black, I think we wouldn't really be quite keen. So you can also make foods taste 10% sweeter if you make them redder. So work by Charles Spence, you give people a berry fruit solution. If you change the lighting, you can affect actually what people think of as the experience of sweetness. Charles is also famous, won the Ig Nobel Prize for his work on Pringles. When you're eating potato chips, if you amplify the high frequency sound of your own crunching, they taste fresher. So do we want to talk about sonic flavor as well as visual flavor? Why not? After all, the brain is getting sensory information in a nice, continuous spatiotemporal way from all of this information. Why don't we bind it all? Why isn't all of that part of flavor? Why not have the lot? Well, one thing you could say is congruency by itself, which people have said, well, look, you only bind the things, the sensory signals that are information that's congruous. So if you're getting congruence between sensory information, then that goes into the package. But of course, color is congruent. The taste of lemon and the color yellow will be congruent, whereas blue and lemon will not. So do we think of unified flavors as congruent sensory inputs? So you think of unified flavors are constituted by congruently related sensory clues, and then congruence could be thought of not as an all or nothing, but as a more or less. So something is more a flavor or less a flavor, depending on how congruent things are. I think that's an unhappy result. But worse is to just understand what we might mean by congruence. What is congruence? Well, let's go back to one of the mechanisms for perhaps binding things together, because even if we've got congruent sensory inputs, how do they get integrated? Why do they get integrated into a single whole? What's the binding? We've got this very important feature of flavor perception, which is oral referral, which Juyun told us about. So an aftertaste in the mouth is actually an after smell. But little is known about the mechanisms. We can behaviorally measure and test that it happens, but what is the mechanism? Why is it that something that is in fact an odor perception in the nose experienced as though it was happening in the mouth? Why is that? Well, you were suggesting maybe congruency might be a way in which we do put things together. The degree of congruency between taste and odor molecules may modulate the degree of odor referral to the mouth. And of course, we see that with this nice study that you and Maxwell Johnson did, if we have chicken and either umami flavor or salt, we get more referral. If we have lemon, it's got to be sweetness, we get more referral. But notice also in the study that you just gave us, caffeine is about as congruent as it could get with coffee odor, but you don't get such a strong enhancement effect. You don't get such a strong enhancement effect of the retronasal odor by taste.
Right.
So congruence is a little bit mysterious in this way, in that when you saw that for citrus flavors you get bitter enhancement with sugar, why is that? And the answer, I think, is obviously clear. You're using undergraduates who are used to drinking sweet fizzy drinks that contain citrus flavors and sugar. In fact, any fizzy drink like Coca-Cola, Fanta and so on, the carbonation is accentuating sourness and reducing sweetness. That's why you can bear what would be an unpalatable load of sugar. So you're getting those combinations already. So it may be that what we should say congruence depends on is not, as it were, something settled by the quality or intensity of the sensations themselves or anything we can find out about the inputs, but when they occur together in nature, when we find the texture, the softened, mushy texture with the smell of isoamyl acetate and a bit of sweetness, those are congruent because bananas have all of those. So if we tend to think that something counts as congruent in your experience, it may be because it's actually tracking the co-presence or the configuration of those sapid, odorous and textural elements out there, which would make it seem as though it's flavors in the world and not flavors in the brain that we should be concentrating on. So as I said, the problem of flavor experience is the extent of it, and we also are left, I think we want to use this distinction. Yes, color can have an effect on our experience of flavor. Yes, sound can have an effect on our experience of flavor. But these are only causally affecting, not constitutive elements of a flavor experience. So when you're actually detecting flavors, when your sensory apparatus or your flavor system is tracking things in the environment, those experiences can be modulated, can be affected by other things that come in and knock them off course or distort them. But we want that distinction between causally affecting and constitutive elements of it. And you don't get that from just knowing which elements are present. And I don't think you get it just from deciding what congruence is without relation to the external environment. So in opposition to Dana Small, I would say flavors aren't made by the brain, flavors are made by nature and by chefs, really. But let me just finish with something which I think is sort of interesting, because you were talking about the integration, and I think that's right. Integration is important, but here's something also interesting. Usually when we integrate retronasal olfaction and taste, we can't then pull them apart. Once you know, if you hold your nose, you get taste, and then you let in the odor, it now just fuses, and you can't pull them apart. But look at this case. If you've got, if you're tasting menthol, the molecule, you get three things. You get a minty aroma, a slightly bitter taste, and a cool sensation in the mouth. And although that's a flavor, if you take any one of those away, you're not getting the flavor of menthol. You can actually pull those apart. Just as when you brush your teeth and you're tasting your toothpaste, you're very aware of the odor. The odor is an odor, it's not just a flavor. So could it be that the boosting of that odor by the trigeminal activation, that coolness in the mouth, which is congruent with mint, people think of coolness and mint going together, there's a sort of congruence there, but it's a little hard to say why it should be there. But you might think that you're able to actually separate and keep those otherwise integrated flavors apart when you're getting a massive enhancement of the retronasal odor by the trigeminal irritation, and I think that might be something also worth investigating here. I was going to just embarrass Jay by saying that he had quoted in a paper of his this remark from Murphy: when an aqueous but tasteless olfactory stimulus is placed in the mouth, subjects consistently interpret the sensation as a taste, rather than a smell. Instead, the flavor is centered on the tongue, even though the sensory perception is principally mediated via the olfactory system. But your discs say not. So we should go back and ask what Murphy was doing here. Okay, but that's it. Thank you.
Thank you. Then, Juyun. Questions?
Thanks very much for the talk. I was reading today's very interesting and like what Harry's commented on it as well. So, if congruency or flavour isn't in the brain, it's just it's a tracking of environmental congruency, and environmental congruency, that's the amount of the brain taste and the flavour. Can we flip it? Can we train it? Can we train people to associate different tastes, pure tastes, pure retronasal smells, and change congruence, right? Because what you're showing is that, I think it's familiarity.
It's through associative learning.
Right, so could you change it? Could you teach, could you give somebody, could you train people to associate different pair, and should you get the same effect?
Well, yeah, associative learning, some point have happened. Why people perceive sugar and citral are congruent, because they've had it at some point. So, are you asking to reverse to what we had and then go away?
To demonstrate cause, right, rather than just correlation, looking at what occurs in the environment and looking at what occurs when we perceive these things. To demonstrate cause, change it. To teach people a new pairing.
I think that's totally possible if you're thinking about unfamiliar orders. Some, like let's say some unfamiliar food order that you never had it before, and then start causing, like pairing up with a different tastes. I almost bet that it will happen. In terms of reverse, it will be hard. It's hard to wire. At some point, it's just there now.
What about vanilla? Because vanilla, as you showed, it's very paired with sugar. So if you smell vanilla, you say it smells sweet, even though it's not sweet.
Right.
But with some cuisines in Southeast Asia, where they only mix it with salt, they wouldn't think it's sweet when you smell it, because they will put it with salt or with fish and not with something sweet. So could you add the saltiness by repeated exposure to those combinations?
Right. I think that's totally possible, because essentially it's that vanilla really smells sweet, or is that, order is interesting. It's a naming problem a lot of times. You have a million kind of compounds out there, and at some point we have to learn to call it. So we have this odorant library in the lab, and then sometimes we smell it like, yeah, I know what it is, but I don't know what to say. And we keep pushing people describe it, and the only thing we get it is through what they know. So oh yeah, it's kind of sweet. Well, because they had at some point vanilla in the context of sweet samples. So they will call it as sweet, not because it's necessarily sweet per se. So if going back to your comment, yes, if we have, if someone pair vanilla with salt all the time, saltier cuisine, someone might say oh, it's kind of salty. I think it's possible.
Isn't it also a consequence of your view, though, that if you got a new dish with an odor and a taste you'd never combined, it should really be a flavor?
Well, I had a lot of, I remember talking about this, thinking about myself, at some point, what is the flavor object? Really, what is it? Well, we can call it as banana, or lemonade is a flavor object. But what if someone give me certain new pairing? Some point, my friend said, well, I made this prosciutto wrapped watermelon, and I said oh, I'm oh, this just doesn't sound right. And he's oh, I would not have it. Once I have it, oh wow, that's congruent. So I had this like photo. I have been thinking about what is really congruency. I mean, you can have two different definitions essentially to me in my mind. One is, well, things are harmonious, and then you have had it together, commonly having together. That's in what I used in my studies because that was more straightforward. But essentially, when I think about like protruder-red watermelon, well, something are naturally congruent. I never had it before, but it goes well together. So which one comes first? I mean, that has been my sort of philosophical struggle, like which one is truth? You know, is there anything innate in it that's congruent naturally, like vanilla in sugar? Is that reason why people put things together, or because it was put together, now it is congruent?
Good question.
I'm trying to struggle with some of your vanilla data. So if you present, I guess in one of the first experiments where you can deprive them of the textural component, and you give them the vanilla to the mouth, and they don't report vanilla.
No, they do. They do report it's vanilla. They do. Certainly it is vanilla, for sure.
Oh, so it's just that they're not reporting to the...
They report it's more to the nose. Like, you know, what is interesting experiment. Once you have it, so when you inhale, exhale, and then in the presence of saltiness, for example, something is salty in my mouth, something is like vanilla in my nose. It's a very distinct sensation you can separate very easily. But in the presence of sugar, all of a sudden you cannot distinct anymore. So all of a sudden everything is coming as if from the mouth. It's not that people have struggle calling it vanilla. It's for sure vanilla.
So what, did you show a data slide where there was some kind of breakdown in the fundamental odor identification with that appropriate taste constituents?
What do you mean in terms of taste side of it or odorant side of it? We always ask vanilla and everybody essentially agree that it is vanilla. In the presence of congruent and incongruent taste.
For you were asking that.
Yes, it's related to this idea when you have a taste and a smell which is incongruent, and therefore you said you experience something in the nose and something in the mouth. But is there a way to distinguish the case where you're conscious at the same moment of these two objects, and versus the case where you can't sort of attend to the two as components of the same object, part of the same flavor thing? So your attention is switching, so you're conscious first of the smell, then of the taste, and first and so on. Do you have
Well, essentially in the presence of incongruent tastes, when we had this odor referral study, that's exactly what's going on. You can separate them pretty clearly. It's like, once you have it, like, oh, there is a sourness in my mouth, and then there is vanilla going on, and then like, it's like you see something and you hear something different in incongruent, unmatched information. So it's to me what it is that, yeah, of course you can taste two senses separately, and that's how it works until it is really perceived as congruent pair. So then it's information processing in my mind that, yeah, there is this smell, there is that taste. It's like you hear something and when you see something totally incongruent, like mismatch when you watch TV. There is a sound and then there is a delay, there is a visual image and then there is delayed sound. You can totally separate them. But once they are matched up, like sync in time, and then you see it as one information all of a sudden, instead of two. So it's information processing in a way. So when there are congruent information, why do we separate them as two informations versus it makes sense to get it more efficient to get it as one.
I'm a bit worried about the definition of congruence and the possible confusion with the aesthetics, that you're almost defining congruence as what's pleasurable. Your example of what you did on the watermelon.
Right.
I'm thinking of an experience I had when I ate something called sea squirt in Japan, which is a huge delicacy, and I can't imagine why. Because it has an incredibly pungent ammoniacal smell. And when you take it into your mouth, you don't actually, not highly volatile, because you don't get it in advance. So you put this object into your mouth, and it's alive, it's seafood. So you put it in your mouth, and it has, of course, saltiness and texture. And then suddenly you get the burst of ammonia. They're completely separate, and in no way, aesthetically are they congruent. There's no kind of hedonistic association between them. But obviously they're congruent in the sense that they're coming from the same food.
Right, but by definition I use, it was incongruent for you because it's the first time you're getting it. So for you, so the smell of ammonia and then taste of a little saltiness, it's like your brain is essentially trying to figure out what is it. There is this ammonia going on, there is a saltiness going on, and it's all separate because at this point, what you're trying to do is like, what is it? Like information processing. But I'm sure once you have it many times, later on, that is becoming what it is. So it's perceived, I'm sure it will be perceived more unified flavor.
I mean, to me, congruence is what's familiar.
So it's associative learning that determines
That's how I
congruence.
view it.
This is a debate that's been had, of course, in vision and Treatment's work, particularly on the conjunction of colours and forms. The final conclusion from that was that although some conjunctions are very frequently experienced, almost no true unitized representations are formed. Subsequently, the work with Dan Kahneman suggested that there are a few unitized colour shade combinations, bananas and carrots, for instance, but almost nothing else. So we seem to be able to perform that kind of unitization within attention very rapidly, rather than having to form an associated representation.
That's interesting.
But to make it more complicated, there's another concept that to me, like I was talking about congruency, which in the context of EI is based on previous experience. That's how I defined it in my study. But at the same time, natural congruence, harmonious, which is more what you are talking about. But then there is a third kind in my mind that, what about perceptual similarity in terms of quality itself, not necessarily, hedonic value added, right? So vanilla and sugar can be really perceptually somewhat similar, versus, let's say, sugar and citral are not perceptually similar, although it's congruent. They are congruent because they are, commonly presented together a lot of times, but they are not really perceptually similar, perceptually distinct. So, yeah.
So just get back to you were first.
Yeah. I had a question. If I got your blogs right, then it was the case that there were some people, if you match vanilla together with the sweet taste, who still thought that it was coming from the nose and not from the mouth. Did you follow up those people? Or maybe I misunderstood it in total.
And there are people who perceive more in the nose.
Yes,
after.
exactly. So it was not a complete effect that everyone perceived it in the mouth, but there were still some people left who perceived it in the nose.
There are some people but that's very rare. Mainly it's happening they report as if it's happening in the mouth.
Exactly, and I was so interested in those very rare people. If they are for some reason different, maybe because they did not associate vanilla together with sucrose for some reason.
Right, but I mean, that can be easily figured out by looking at their experience together. But on purpose, we picked stimuli that are very, very common. So it was very, very rare. And essentially it was more of an outlier.
On your cat, are they only allowed to say one anatomical region?
Multiple.
They point at that diagram you have.
Right. So
Right, but can they point to more than one place?
yes, it could be one place, one location. It could be two locations. It can be multiple. It can be front of tongue, back of tongue. It was multiple. So just.
Did you want to just place?
I think that's okay, but if they want to see. Yeah, it was essentially, we told them it could be multiple places. And then fairly commonly, people reported, I think it's coming, it's just a little slow. Right. So in the very earliest study, we gave them even more complicated because we didn't know what to expect. So we gave front of tongue, back of tongue, front of nose, back of nose, oral cavity, even throat. Essentially, no one reported to throat, like almost zero. A lot of times, people would say front of tongue and back of the tongue. So it was very much overlapping. So eventually, this is why we deleted, like, okay, there is no need to have separate front and back. But commonly people would say, yeah, it's very, very confusing. Those people who might report still in the nose, they would say, yeah, it's a nose, but at the same time in my tongue, or my tongue as well. So it was very rare to someone in the context of, in the presence of sugar with the vanilla. Not many, essentially no one reported nose only. It's combination of nose and at least tongue or oral cavity. But mainly like front of tongue and back of tongue, or oral cavity and tongue, like that.
Can you show the data from one of these? Because I think it speaks to her question.
I don't have that data here, but I think in the publication I might have.
Well, you showed something.
Here, right? So frequency data, so when there is error, about 14 responses out of 22. But remember, these are multiple responses. So in other words, they had choices of reporting either one location or two locations or three locations, how many they wanted. So altogether, it's greater than 22 responses for each section. But for air, it was about 14 people out of 14 frequencies out of a total of what? 14, it's more than 22. So about 55% they reported as if it's coming from the nose. But if you look at sucrose, it's all of a sudden 17 people responded coming from tongue plus about 7 oral cavity. So altogether, it's essentially everybody.
But there's still 11 or so saying nose.
Right, because people reported nose and tongue
But
or
then,
nose.
so you're saying that most people, if they report nose, they're also reporting tongue.
Tongue or
That
oral cavity.
There's few people who would mostly say just nose.
Yeah, there was essentially no one. So essentially everybody reports, in the presence of sucrose, everybody reports either oral cavity or tongue. And then some people will, at the same time, nose as well.
It seems that the congruence is from experience. I'm just wondering if there's any innate congruencies. Has been studies done maybe on infants to see if there's some innate, hardwired congruencies in humans or maybe animals. I'm not sure. Has there been studies like that?
No, not that I know of. But I think definition I used in terms of congruency was based on previous experience. But essentially what we can do is that have new odorant that, certain food odorant is a certain food you like, but you never had it before. Like a certain, South Asian fruit that you never had before. And then you have that paired with certain tastes, then you can test them, essentially. So
what's your conclusion? Do you think there is any innate
Well,
congruencies?
based on my definition, it is really based on experience.
Oh, okay.
But as you said with the watermelon and the pineapple,
Right.
if there really are principles of flavor matching, and if there is a paper published in Nature that is absolutely false, and it talks about there being
Most of them are.
chemical reasons, molecular reasons for flavor pairing, and they drew a flavor network and got a lot of attention. It's
Right.
rubbish. But if it was the case that you find that there were some chemical reasons for
Right.
flavor pairings, then that would be interesting.
Because essentially, if you have a certain odorant, like a certain tropical fruit you never had before, they can also have similar volatile, like out of 200, 400, volatiles existing in each fruit. There are some overlaps. If you think about pineapple and mango, it's very distinct, but there are overlapping volatiles.
Exonerate.
Right. So if you have certain fruit order that you never had before, they could have certainly similar enough in terms of component with, let's say, pineapple or mango. Then it's loosely, congruence can happen much faster.
Yeah.
So I think there's one important point to be raised, which is it's a highly risky proposition to put something in your mouth if you don't know what it is.
Right.
And that's why
Unless you're
experience.
paying a lot of money to a chef.
I'm thinking about my core, terrier mix. And so this learning about that is very important. I suppose there could be some innate things that.
The kids put things in their mouths all the time,
Yeah.
immediately. They don't inspect them and sniff them before treating them.
But animals don't typically do that, do they?
Cigarette. Some things.
That's a good observation. But I don't know if animals typically do that.
Kids are also doing social reference just after. So they are learning from the parents that it's for them.
And not every kids are that way either. Certain kids are more, not willing to try anything new.
I'm talking, real neonates.
Right.
Pull things to the mouth immediately, and then reject them if they're bitter or whatever. Very willing to put things in their mouth.
Have you worked with people who have lost their sense of taste? Because it could be interesting to how they experience location now.
Right, I have not had those subjects.
Do you think it would be something interesting?
Yeah, there would be, but it's like, to me, like I see a lot more people who suffer, smell disorder, not taste disorder. So
Yeah.
I have not came across anybody.
I see some patients with smell loss and a couple with taste. And in the literature, it's generally stated that patients with taste loss are much more devastated, which kind of speaks a bit to the concept of flavor as an object.
But you don't get, do you get congenital dysgeusia, or is it just, because you do get pretty rare, right?
But chemotherapy can often cause thyroid dysfunction, inflammatory disorders.
You wonder if people would survive if they actually had it congenitally, because food choice would be really difficult if they're not doing any binding at all. It's all just odor-based.
Right. Yeah, the patients report everything tastes very much like cardboard. I think that your mission to redefine maybe what how we should approach the concept of flavor is a very intriguing one. And I think part of the issue is semantics right now. And I generally avoided using the word odorant today, but I did mention it. And I think that's a very useful concept to have the odorant, which is the physical stimulus, from the odor that is the percept. And I think I've seen the word, but maybe we should try and more formally embrace the term flavorant, which defines the flavor stimulus and can separate it from flavor as the percept.
I mean, that's a very interesting situation. I think the hard part would be there are this industry, right? Flavor industry. They use the term flavorant for odorant, essentially. So flavor chemists use that, the word totally different way. So to them, flavorant, when we talk about flavorant, they talk about specific odorant.
Well, it's going to be hard to change marketing.
Right.
For a while.
Yeah, semantics matters, that's right, because otherwise we're cross purposes, very small and stuff like that.
This is time for a break.
Time for lunch.
Very good.
Which is
Back and
back.
back. Thank you. Thanks very much.
Thank you.